All right, oh my goodness, will this review ever end? Here we go. Letter I. I am going to go with the left side. It looks like you got a lot of stuff happening. Now, my least favorite identity is right there. Why? Because there are three options. I could go with cosine squared x minus sine squared x. I could go with 2 cosine squared x minus 1, or I could go with 1 minus 2 sine squared x. If I had to pick right now, if you forced me to pick right this minute, I'm probably going to go with the middle one. But since I don't know that I want that one 100%, I'm just looking at the denominator and seeing what might shake out here. I'd probably go with that one. But since I don't want to commit yet, I'm going to wait till I'm sure. Now this guy over here I want to talk about real quickly. We mentioned this before in class, and I'm looking at cosine squared of the half angle. Now, cosine half angle, let's do the a over 2 because I think that's how it's in your notes, is 1 plus cosine a over 2. You take the square root of that. You got to put a plus or minus because it could be positive, could be negative. It just depends. That is a terrible, terrible formula in a verifying problem. However, you don't have cosine a over 2. You have cosine squared. Now remember, cosine squared means you're squaring the whole thing. It's just we don't want to write it that way because that's a real pain. So we put the squared in between the cosine and the a over 2 just for convenience sake. But this is what it means, which means you are actually squaring this big mess. And we said, when you square a plus or minus, you square a positive, it's positive. You square a negative, it's positive. This is going to become a plus. When you square a square root, you're left with the radicand. It's just going to be the radicand, assuming the radicand's positive. Now, if that's negative, we got a problem with the square root for sure. But we're going to, on this problem, not worry about such an issue because we're not going to be dealing with imaginary numbers. So if we square this, we're just left with something that is relatively friendly. 1 plus cosine of a over 2. That's not too bad. And that's exactly what I'm going to replace this guy with. There we go. So I said I'm not committing to cosine double angle yet. I don't know. But I do have to write down the minus 2, and I'm going to multiply it to this guy squared. And like I said, it's a proof. Unfortunately, we got to write that. Got to write these steps. So let's not say a, we'll say x over 2, but we are squaring you. We are adding 1, and we are dividing this whole thing by cosine of x minus 1. Now, the math is already shown. This just becomes 1 plus cosine of x over 2. So I got cosine 2x still waiting to decide. That's 2. 1 plus cosine of x over 2. That cleans up rather nicely. And this is over cosine of x minus 1. All right, the 2's will cancel. Watch that negative, which does need to be distributed. That would be one thing that would drive you nuts on this problem. You do everything right, but forget to distribute that negative, and you're wondering what is going on here. Why aren't things canceling like they should? You got to be real careful. So the 2's do cancel. We get cosine 2x. I will soon decide what I want you to be. Minus, I'm distributing the negative through 1 minus cosine of x plus 1 over cosine of x minus 1. If you don't distribute the negative through, you're going to get negative 1 minus 1 more, and you'll say that's negative 2. That's not good. And it's not. We'll distribute through. All right, so I said I was going to commit. I'm not committed yet. Cosine 2x. The 1's do cancel. I get minus the cosine of x, and this is all over cosine of x minus 1. Now, the question is, which one of the 3 do I want? Well, it would be kind of nice if everybody was cosines. That produces factoring opportunities and the like. So I'm going to go with the middle one. I don't really see an advantage to the other 2, so it's a direct identity, so no justification necessary. 2 cosine squared x minus 1 cosine 2x minus that cosine of x that was already there over cosine of x minus 1. Don't get any crazy ideas. Don't think of canceling yet. I'm going to rearrange the terms. This is really the trick to the whole problem. Minus 1 over cosine x minus 1. Yeah, you can tell. Right, again, don't get any crazy ideas. The heart method, not a good idea here. I don't think that's going to produce anything, seeing how this is negative, negative. That's positive, negative. Even if you split this up into two fractions, both with this denominator, it's just not going to happen. What I'm thinking, this numerator is very similar to the trinomial 2x squared minus x minus 1. Replace the x's with cosines, and you will have this numerator. So if you think of 2x squared minus x minus 1, that guy factors. Factors into 2x and x. Well, it's going to have to be 1 and 1 outer. We'll need a minus. Plus, that is how 2x squared minus x minus 1 factors. How does this guy factor? Well, replace the x's with cosines, and we will have it, I think. So we get 2 cosine x minus 1, plus 1, sorry. And over here, cosine of x minus 1. And this is all over cosine x minus 1. And now you are free to cancel common factors, leaving you with 2 cosine of x plus 1. I mean, I wrote this much, might as well finish it. Plus 1 with the check mark. That is the right side. All right, letter J, last one. This guy, again, it looks bad, but be happy when you see sine squared and cosine squared of the half angle because it comes out very, very nice. So let me just put it in. It looks bad at the start because I have to put in the entire problem for a sine half angle, which is 1 minus sine x. You didn't see that. Cosine of x over 2, and you do have to square it. And then same thing for cosine squared half angle would be plus or minus giant square root, nice bar in the way, 1 plus cosine x over 2, and we do have to square that. All right, I gotta be careful not to write past there. All right, that comes out really nice. We get 4. That just becomes 1 minus cosine x over 2. This becomes 1 plus cosine of x over 2. If you multiply these two fractions together, numerator and denominator, you notice the numerators, they are conjugates, so you only have to go through first and last. And, convenient. 2 times 2 is 4. Wow. The 4's cancel. Very convenient. 1 minus cosine squared. I'll write that. Happens to be sine squared. Assuming you justify that step as sine squared x plus cosine squared x equals 1. And yep, that's what we had to prove. Done. Take a look at things to think about next.